Hello, welcome to SmartCo Academy, giving you science courses online. Last time we have looked at linear expansion as one of the subtopics under thermal expansion. Today's class, we are going to look at area expansion. Click on the subscription button down below this video. Give me a like, comment in case of any clarification and more about this course. Linear area expansion, Area expansion uh, is an increase in the area of a solid or a metal compared to linear expansion where there is only an increase in the length. But for this one here, there is a gradual increase in the area of a solid or a metal. Therefore, linear expansion is an increase in the area per unit area per degree rise in temperature. Mathematical expression Mathematically, area expansion is represented with a Greek letter that is beta. We say beta is equals to change in area. Change in area is also written as delta E all over the original area. Original area is area 1, which is the initial area also, times change in temperature. Change in temperature is written as delta T. You can also break this equation down by change in area is A2 minus A1 all over A1 into bracket T2 minus T1. That is the formula for this area expansion. Don't also forget that area expansion is related to linear expansion. Let's see the relationship. The relationship between area expansion is a beta is equals to 2 alpha. That is the relationship between area and linear expansivity. So we are going to look at some problems on how we should solve problems under area expansion. Let's do example 1. So this is our example 1 under area expansion. Say given that the linear expansion of the metal is 0.00267 per Kelvin, what is the area expansion? Here we are given the linear expansion, but we are asked to solve area expansion. Let's say solution given we are given the linear expansion that is alpha as 0.00267 per Kelvin. We are asked to solve area expansion that is beta as being equals to question mark. If we go back, we say that beta is related to alpha. We are going to recall this formula. Let's say recall beta as being equals to 2 alpha. Therefore, now we are good to solve these problems. Let's say beta as being equals to 2 multiplied by alpha. Our alpha is given as 0.00267 per Kelvin. So we are going to multiply through, let's say 2 times 0.000.0000267. We're going to get our beta as 0.0000534 per Kelvin. And that is our answer for example 1. Let's look at example 2 and we'll see how to solve problems under area. This is our example 2 under area expansion. Says, what is the initial area of a lead box if the area increased to 27.0 meters square after it was heated from 20 Kelvin to 52 Kelvin? Take beta as this figure which is given here. Here we are looking for the initial area. We are given the final area, we're given the final and initial temperature, and we are also given the beta expansivity. So let's look this down the given parameters. It says solution. We say given. Here we are given what is the initial area of the lead box if the area increased to. If the area increased to, that means that one is our final area, which is area 2. has been equals to 27.0 meters squared. After it was heated from 20 Kelvin to 52 Kelvin. This is our initial and this is our final. Say T1 has been equals to 20 Kelvin and T2 has been equals to 52 Kelvin. In the bracket there we are given beta 0.00028 per Kelvin. And we are looking for the initial area, which is question mark. Now let's recall our formula. Recall as what? Beta is equals to change in area all over the original area, which is area 1, times change in temperature. You can also write it as A2 minus A1 all over A1 into T2 minus T1. Here we are going to substitute our values. Let's say beta, the value of beta here is 0.00028 has been equals to A2. A2 is 27.0 minus A1 all over A1 into T2. T2 is 52 minus T1. T1 is 20. Here we go. So we say 0.00028 is equals to 27.0 minus A1, the whole of it all over A1 into 52 minus 20, we will get 32. That is 32. Here we cross multiply. We multiply this and this, and the other one times the other one. When we multiply this and this, we get 27.0 minus A1 is equals to, you multiply this times this one. You first open the bracket. You open the bracket, you will get 32 A1. So let's multiply this times this, 0.00028 times 32 A1. Now we see. Here we have A1, there we have A1. We take this A1 to the other side of the equation as we collect like terms. We say that 27.0 A1, 27.0 is equals to 0.00028 times 32 A1 plus A1. If you take minus A1 to the other side of the equation, you will get positive A1. Let's continue from this side. We bring the same idea. 27.0 is equals to 0.00028 times 32 A1 plus A1. Here we have 32 A1 and we have A1. The coefficient of A1 is 1. We add them. 32 A1 plus A1, you will get what? 33 A1, because the coefficient here is still as 1. We're going to say 27.0 is equals 0.0028 times. If you add this one, you will get 33 A1. Now we are going to multiply. We multiply this times this one. If you multiply 0.00028 times 33, we will get, let's say 27.0 is equals to 0.00924A1. Now from here, we divide both sides by this here, say that we make A1 as our subject. 0.00924 and 0.00924. This one cancels. We left with A1 as being constant. 27 say 27.0 divided by 0.00 divided by 0.0. Okay, let's say 27.0 divided by 0.00924. We are going to get 2922.08, and it is in meters squared. So this is our final answer of our example 2. We have come to the end of this class, area expansion. Subscribe to my channel, like, give a comment in case of any clarification or any other topic that you may need help in courses concerning physics and mathematics and other sciences. See you in our next class. Thanks.